Okay, moving on to part 3 of the handout. Let's now look at a better approximation, this time using a second order RK method. Okay, this time instead of defining the slope as just the derivative, okay, it's defining m, we're going to define m as a weighted average of two slopes. We're going to call them m1 and m2. Okay, so slope is just going to be c1 m1 plus c2 m2. And we're just going to take the average. So it's just going to be c1 is 0.5 and c2 is 0.5. Okay, so in other words, in our code right here, we basically have the same code, except that we're going to change this m right here. So if you don't want to retype everything, what we're going to do is just save this as a different file and then modify the revised file. Okay, so you go back here, make sure you save your file, and now save it again. Save it as, this time give it a different name, and call it, instead of Euler, call it Heun, H-E-U-N. Okay, the Heun method is a second order method. It's an example of what's called a predictor corrector method. So now I have my original already saved. This is my second one that that you'll need to upload later after you've modified it. Okay, so how are we going to modify this? Well, let's go back to our macro right here. Like I said, what you need to do is basically change the definition of m right here. You need a better estimate for m. And how are we going to do that? The idea is this. Let's say you have y1, t1 over here. So you have t1 and you have y1 over here, right? So t1, y1. You get the slope over here, okay? And then you predict what it's going to be at t2. So our prediction for t2 would be over here. So this will be your y2. But we're not going to take that as the correct value. We know there's going to be an error there, right there. So we're going to say, okay, I'm just going to call this a tentative y2 because I know it's not perfect. But at this tentative y2, I can recalculate my slope. So the slope over here is m1, okay, and then the slope over here is going to be m2. And then I'm going to take the average of m1 and m2, and that's going to be my m. You can see it's steeper over here. It's not quite as steep over here. Then maybe, you know, the m you're going to get is not quite as steep. It might bring you closer to the correct value. All right, so that's the idea. So you calculate two slopes. So the first slope you calculate, m1, is basically what m was before, right? So what we're going to do is we're going to say, okay, so now, and now we're going to call this one, instead of Euler, change it to Heun, H-E-U-N. All right. And then let's go back to our code, this RK1, okay. Edit the text. It should now say RK2. Second order, okay. And then right click on it, assign macro to it. You should now assign Heun to it. Okay. And we're gonna get rid of what we have here, the ones in green, because we're gonna recalculate that. Okay, still with me? Okay, and make sure you've already saved it as Heun. So now what I do is, okay, I'm gonna say, okay, change this, right? We're gonna change that. So now we're gonna say M1 is what we had before as M is M1. We're gonna call it M1, dy dt t1 y1. But we need to declare M1. So up here, over here, we're gonna define M1 as double. Okay. We need M1. We're introducing a new variable called M1. So we're going to put it there. We have to define it. So now M1 is what M used to be. And then we're going to do M2. How do I do M2? Well, first of all, I need to calculate a tentative Y2. Okay, so dim tentative underscore Y2 as double. Okay, what's my tentative Y2? My tentative Y2 right here, this is just going to be equal to Y1 plus M1 times H. Right? So Y1 plus M1 times H. So this tentative Y2, that's my predicted Y2 that I know that one I would have gotten from the Euler method. Okay, I know it's not perfect. So I'm just going to call that a tentative Y2. So what I'm going to do over here, I can say tentative Y2 is double. So I'm going to say tentative Y2, tentative underscore Y2 equals Y1 plus M1 this time times H. Instead of M times H, I'm going to say M1 times H. Okay? So I got my Y2. Now I want to get the derivative at that Y2, at that T2 and tentative Y2. So I'm going to say M2 is equal to dy dt at T2, comma, and at that particular T2, my value of Y is my tentative Y2. Tentative underscore Y2. Okay? Now, since I'm using M2 here, I have to define another variable up here. I'm going to say dim M2 as double. So I have to add these three variables in my declarations. Okay. And so basically I have my M1. Based on my M1, I predict what my tentative Y2 would be, my Euler value. And then I calculate the slope at that other point and then average the two slopes. So my final M here is going to be the average of M1 and M2. So 0.5 times M1 plus 0.5 times M2. And then this last part is the same. It's just Y2 is Y1 plus M times H. Okay? Changes and here. Okay, so you have your Euler statement. Basically, you're replacing it by these four numbers. Okay. And let's see if that works. Did I record? Yeah. So now I'm going to calculate R2, and there it is. RK2. Look what happens here. Look at my error at 1/2 life. What was my error before? 5%. Now my error is only 0.24%. Second half life, my error before was how much? 10%. Now it's only 0.5%. Way better, right? Than the first order approximation. So now that I've got this one done, I save it. Okay, so make sure that the header for column C is now Heun, okay? Save it. And then we're going to save this as another file name when we make another modification to make it a fourth order correction. And now let's save it as, this will be your third file now. Save it as RK4C, last name underscore RK4C. This is the classic fourth order RK method. And this is the most commonly used method for doing these types of problems, okay, because this will give you really high accuracy. So RK4C. So I'm going to change this RK2, edit the text. This is now going to be RK4C. RK4C. Adjust the size. Okay. And what I'm going to do is now I'm going to edit my code. You can see it now says RK4C. And so we're going to change, this one right here is no longer Heun. This is now going to be RK4C, right? And then in your code, all right, it now should say sub RK4C. And then go back here to your box, assign macro. You want to assign it to RK4C. And now let's modify RK4C. But before we do, let's just go ahead and save it again. So now let's go to RK4C. What does RK4C do? This time, by the way, there are questions you'll have to answer based on the Heun method right here, okay, for your handout. So for RK4C, fourth order Runge-Kutta method, this time we're going to calculate 4 slopes, M1, M2, M3, M4. Okay? And we're going to say M would be a weighted average of these 4 values. So basically at the end, we're going to say if we've calculated M1, M2, M3, and M4, we're going to add M1 to M2, put twice as much weight as on M2, put twice as much weight on M3, and then same weight for M4 and M1. So 1 plus 2 plus 2 plus 1, that's 6. So the total weight is 6, so divide the whole thing by 6. So that's your M. So we just need to know exactly what is M1, M2, M3, and M4. Okay, so we have, that's why it's called fourth order. There's 4 slopes that you're calculating to estimate your M. All right, same at the very end. It's just y2 is y1 plus m times h. So let's just make that correction right now. We can say this is still the same, right? So what would be my m here? So let me get rid of all of these. So what's going to be my final m? Is m1, parenthesis m1 plus 2 times m2 plus 2 times m3 plus m4, the whole thing divided by 6, right? I just need to figure out what M1, M2, M3, and M4 are. So before I do anything else, I've already declared M1 and M2 previously, right? So I have to declare M3 and M4. Then M3 as double. Oops. And then M4 as double. Okay. So how am I going to calculate M1, M2, M3, and I took out tentative Y2. So M1 is the slope at T1, Y1. That's basically the same M1 we have before. So that's easy. So let's go ahead and put that back in. I can say M1 is what used to be my M in the first order. So equals dy dt at T1, Y1. Okay. Now we're going to predict what is y going to be at the midpoint of T1 and T2. All right. So so let's calculate TMid, the midpoint first. So let's define that variable. TMid, so dim T underscore mid as double. So TMid is the halfway point between T1 and T2. So if this is T1 and this is T2, so there's your curve right there. TMid is over here. How do I calculate TMid if I know T1 and T2? T1 plus T2 divided by 2. Or I know this is H, right? So the difference here is going to be H over 2. I can also say TMid is T1 plus H over 2. Either one's fine. You can do T1 plus T2 divided by 2, or you can say T1 plus H over 2. So that's my TMid. Okay, so let's calculate TMid. And where are we going to do that? Let's do that over here. T underscore mid equals T1 plus half of H. Okay, I got my TMid. Next thing I need to do is I'm going to predict what Y is at TMid using M1. Okay, but I only go halfway, so I multiply M1 by H over 2 instead of multiplying it by H. So in other words, based on here, I'm basically knowing M1 over here is my slope. I'm going to predict what this is right here. So this is, I'm going to call this Y mid. Okay, so Y mid is going to be Y1 plus M1 times H over 2, right? So Y mid is equal to Y1 plus H over 2. So Y mid equals Y1 plus M1 times H over 2. Okay? I got my Y mid, T mid, and Y mid. That's this one, this point right here. This is T mid, and that's Y mid. And it's based off of M1. Now I need to know what the slope is at this point. What's the slope at that point? That's going to be my M2. Okay? So the slope at that point is going to be my M2. So M2 is the slope at T mid, Y mid. All you have to do is call dy dt and give it T mid and Y mid. So what I do now, I'm going to say, what is it? M2 equals dy dt at T underscore mid, comma, Y underscore mid. Okay, T mid I already defined. I have to define Y mid up here also. So dim Y underscore mid as double. Okay. So I got my Y, my M1, I've got my M2. 2 more M's to go. What's my M3? Oh, this time we're going to predict Y again at TMid, this time using M2 instead of M1. Okay, so the new, let's call that the new Y mid. It's going to be Y1 plus, instead of M1, we're going to use M2. So we're going to predict again. Now that we know this slope, we're going to predict again what that, so this is going to be a slope M2. This is my new Y mid right here. Okay, you can see we're triangulating, we're homing in on where the correct value of Y is. So that would be the new Y mid. So it's going to be Y1 plus M2 times H over 2. All right, so we're going to say new underscore Y underscore mid, okay, equals Y1 plus, instead of M1, I'm going to use M2 this time, multiply it by H over 2, just H over 2 because I'm only going halfway to the interval, okay? But now I have this new Y mid, I have to define that variable, so go back up here to my new variables. I'm going to say dim new underscore Y underscore mid as double. Okay? So I now have my new Y mid. Now that I've done that, My M3 is the slope at the new y mid, at that next point. So in other words, now I have this point over here. I need the slope over here. This is going to slope over here is going to be M3. Okay. So I've got my M1, M2, M3. So take that slope. So M3 is going to be equal to dy dt at TMid, comma, new y mid, new underscore y underscore mid. Okay, so I've got my M1, M2, M3. So that's a slope at TMid and new y mid. So I know my M1, I have now my M2, I have my M3. I just need my M4. What's my M4? Well, I'm going to predict now, okay, what y is at T2 using M3. So using this M3 that I have, I'm going to now make a prediction. So M3, I'm going to predict what my Y2 is going to be here. Okay. So I'm going to predict a new Y2 there. So Y2, this is Y2 is equal to Y1 plus M3 times H, because I'm going to go all the way to the other side. So this time is going to be Y2 is equal to Y1 plus M3 times H. Okay, that's actually a tentative Y2. Okay, because my final Y2 is down here. I should have kept the name tentative Y2, but I did not. So let's just follow the handout. So that's your Y2, tentative Y2. I'm just calling it Y2. And now I can calculate M4, the slope at T2, Y2. So now I have that. I need the slope there. That's going to be my M4. Okay, so if I know the slope there, that's going to be my M4. So the slope at that point is going to be M4. M4 is just dy dt at T2, Y2. Okay, and now I take the average of all those m's, divide by 6. Okay, because I'm getting a weight of 2 for M2 and M3. And then, so those are the changes I have to make. And let's make sure it's working. So now this is linking to, this should be assigned to RK4C, so it's good. So if I get rid of these, and click RK4C, look at the results. Look at my error. 0.0002% error, practically almost like the exact answer. Okay, 0.25 right here, 0.00047% error. So you can even tell the two apart from the graph. They're just right on top of each other. Okay, so that's how you can tell that your answer is correct, that your code's working right here. Okay, 0.0007% error after 3 lifetimes. So this is a very good method. Okay, so there's your code right there. And so once you've done that, you save this. Make sure you save it. And that would be your third file for today. All right, so you calculate M1. Project it to the midpoint of the interval to get T-mid and Y-mid. Get the slope at that midpoint. That's M2. And then you project again to the midpoint using M2. Okay, and then that gives you the slope at that midpoint. That's called M3. And then you project all the way to the other end using M3 and get the slope at that point. That's going to be your M4, and then take a weighted average of M1, M2, M3, and M4, putting twice as much weight on M2 and M3. Now, where did all of this come from? You're going to have to go into the theory behind that, learn about numerical methods. I can't tell you because I don't. I'm a pragmatic person. I just use it as is. Okay. But a course in numerical method will give you the background information on that. And then finally, y2 will just be y1 plus n times h. Okay, so on to question number 5. You have a second order reaction. Okay. Rate equals k times r squared. The closed form solution is this. Show that this is in fact the closed form solution. So what do you need to do? So here you have rate is minus dr dt is equal to k times r squared instead of just r. Okay. So you do your separation of variables, minus dr over r squared. Okay, you can put the minus on the other side, minus kt. And then you integrate both sides. You have to do that yourself. Okay, I won't do it for you. If you need help on Moodle, there's a link to it. There's some tips for how to do it. Okay, so this video right here should help you out. Instead of using R, he's using A. Okay. So at the very end, you should get 1 over R. And then that's what you learn in your kinetics class, in your kinetics lesson, right? At the very end, you should be able to show that 1 over R is equal to 1 over R naught plus KT. In fact, that's how you analyze a second order reaction, right? You plot this on your y-axis and you plot this on your x-axis. So 1 over R versus time, you get a straight line and your slope is equal to K. All right, and your intercept is 1 over R naught. So that's going to be for you to figure out. I gave you a link there to help you out with that. All right, and then number 6, okay, your RK file, save it as RK4C underscore second order. You need to modify it so that the rate equation you're now solving is this one. Okay, so you're going to need to change your dy dt function. What changes would I have to make? Well, my dy dt function should be what? It should not just be minus k times y1. It should now be minus k times y1 squared. Okay. What else? What other changes do you need to make? Yeah, again, up to 3 half-lives, but your half-life is not going to be, the first half-life is still going to be 10, but your second half-life is not going to be 10 anymore, right? Second order, the half-life gets longer and longer. So you need to figure out how much farther you need to go. Okay, that's why you need to make sure you go through that tutorial on the kinetics. Okay, so half-life for second order is not constant. So the next half-life is going to be twice as long. The next half-life is going to be 4 times as long. Okay, so when you do that, right here, okay, you can calculate your exact R. How do you calculate your exact R, by the way? You have the formula for 1 over R. How do you get R? Whatever 1 over R is, raise it to the minus 1 power, take the reciprocal, right? So, in other words, what do you do? So the way you would enter it in Excel is you need the formula for 1 over R is 1 over R naught plus KT. 1 over that is 1 over R, and that's going to be R. Okay, so you need to change this column right here for R exact, because this what we have here is the R for first order. Okay, now your rate constant is going to be different. Well, how is the rate constant for, so this formula is going to be different too. How is the rate constant for second order different from first order? Review your kinetics lesson. And what should be the unit for this? It's not going to be per second anymore. What is it? It's per molarity per second. Okay, so you need to review your second order rate law. And your number of steps, you're going to need more steps because the half-life get longer. Okay, other than that, everything should more or less stay the same. Okay, you don't have to make much modification to your code. So that's your lab report. So here are some tips for your lab report. So for your lab report, you need the Excel file for number 6, okay? And then the complete annotated Word document with all the answers up to number 5, okay? So 2 files for that lab report. And here's some tips for your lab report. Like I said, this video right here should help you out with number 5. And these are the things you need to look out for when doing the Excel sheet for number 6. Okay. You have to change the formula for the half-life based on the formula for K based on the half-life. Okay. You need to change the formula for the exact R. It's not first order anymore. It's second order. And then you need to change dy dt in the code. Okay. And then you need to stretch out your calculation over a longer Tmax because your half-life gets longer. So if you take care of all of those, you should be fine. And that's all you need for your lab report.